Hi, I'm Adarsh Ambati. I'm 15 years old and I'm from San Jose, California.
My project is called a Smart, Low-Cost, Social Network Connected Community Sprinkler System. During the years of 2011 to 2017, California experienced one of the worst droughts in recorded history. As such, cities began to impose severe water regulations. These regulations for my hometown of San Jose included limiting the number of days, enforcing specific dates and times, and finding any runoffs for residential irrigation. Next, we can see that the two main types of smart sprinkler systems, WVICs and SMSs, have severe drawbacks. Both are relatively expensive, fail to account for all use case scenarios, and do not account for city water regulations. Thus, residents either overwater their lawns or let their yards die. This means that my project goal is to build a smart sprinkler system that is 1. Low cost, 2. Conserves landscaping water for entire communities, and 3. Helps residents comply with city water regulations. Some key innovations in my project are utilizing social media as a means for communication, containing 0 custom components, and using online weather resources to obtain future weather reports. In this functional design, one can see that the center of the prototype is the Raspberry Pi that connects via the relay switch to the sprinkler controller. The moisture sensor is also connected to the Raspberry Pi, and the Raspberry Pi also contains the city water regulations encoded. The device then checks the Piome weather database, and once determining an approximate percentage of total irrigation time, the device then tweets the information to the rest of the community. Here are the sample tweeted messages. You can see that the messages contain both the watering information and hashtags, as the instructions will vary for odd and even numbered houses due to the city odd-even watering schedule. The hashtags allow each resident to only view the instructions for their house number.
Engaging the community through social media, we shed light on a problem that can only be solved through collective, unifying effort.
The final test for my prototype was a pilot study with 10 homes over a 2-month period. The results showed that the total cost for a prototype is less than $50, the cost per piloted home is less than $5, and the cost per home in a community is just a couple of cents. Additionally, the pilot study found that 83% of water that would have otherwise been wasted was saved. Thus, in conclusion, based on the 2 months of data, my prototype met all of my project goals. It was a fraction of the cost of the current sprinklers available. For a neighborhood of 12,000 homes, it can save approximately 30 million gallons per month, or 2.5 million savings per year, and it operates in accordance with city water regulations. Thank you for listening.